So let's begin. I am Bob Resselman, and this is Kubernetes, why it's cool and why it matters. And at the end of the presentation, of all this presentation, is to give you a working vocabulary of the fundamental Kubernetes objects. And these are node, pod, deployment, service, and Ingress. And then I'm going to go into a demo so you can see all of this happening directly on a Google Cloud cluster. And what a cluster is, I'll explain in a minute. The other thing I'm going to do is I have to do some Containers 101. You really can't get Kubernetes unless you understand containers. If you do understand containers, just feel free to put on mute or go watch some YouTube for 5 or 6 minutes or have your dinner, but come back in. But I do owe it to those who are not well-versed in containers that they have that baseline knowledge. Okay, this is who I am. I'm Bob Resselman. I'm an independent consultant. I've worked a lot of places. Now I work in the comfort of my home office in West Los Angeles, California. It's a great place to be. These are all the places I work. I do publish a good deal. I have an ongoing column on DevOps.com and TechOps Agenda, and a number of others. Programmable Web, I have a long-term profile series coming out, and I've done some work for them. I get around, and so I do write a lot, and feel free to write me if you think you have a story that I ought to tell, because I'm sure I can find a venue for that. So that's who I am. And then also the housekeeping on this, there is code and stuff for this. All the code I'm going to show you is out on my GitHub repository under WrestleBob Pinger. And I will post the slides for this deck up on the Meetup site and on SlideShare at the end. My Twitter handle is WrestleBob. Feel free to like me. I can use all the affirmation I can get. There's my LinkedIn profile. Feel free to go there. And also there's my email address, WrestleBob@gmail. I pride myself on answering emails quickly. It really drives me people who don't answer emails quickly. It's a lesson I learned in propriety early on, is answer the emails when you get them. All right, let me set some expectations about what the world of Kubernetes is like in my experience. The big gray circle is Kubernetes. It's a huge, huge, huge technology. The little yellow circle on the right is what we're going to cover today. And as a matter of fact, that yellow circle is probably too big. It's probably a little smaller, but I couldn't get it to go much smaller than it was already. So I want to set your expectations. This is an introductory session about Kubernetes, basically to give you a vocabulary and a basic sense of the concepts that are behind Kubernetes and how they work. All right, so let's start. Why Kubernetes? And K8S is the industry standard abbreviation for Kubernetes. Some people say it's because there's 8 letters between Kuber and Netes. Other people have other theories. I'll go with whatever you got. It's K8S. So Kubernetes is an open source container orchestration system for automating deployment, scaling, management of containerized applications at web scale. And I know I just read off the slide. You didn't come in to hear me read off the slide. So let me tell you this. Kubernetes solves the fundamental problems, not one problem, but many, many problems of having web scale applications operating on the internet. It solves deployment problems, it solves security problems, it solves segmentation problems, fail safety problems, it's storage problems, so everything you could think of. It makes a valid and viable attempt to solve. It's created by Google. It's been in play at Google for 10 years now. It started as Borg. There are competing technologies, but Kubernetes is winning out. Just think of Kubernetes as a way to run the internet, to run your world on the internet. However, you can also do colo implementations. You can run, I run Kubernetes on my internal home cloud because I don't let my network out to the world. So it's scalable on so many levels, but it is a way to run the internet, and Google has an opinion, and this is it. All right, let's do Containers 101. So those of you that know about containers, you know, put yourself on mute and watch some YouTube for about 5 minutes. All right. A container is the current endpoint evolution of computing technology. For the most part, serverless is coming on, but right now we'll say that containers are the endpoint. What do I mean by that? Well, in the beginning, there was hardware. So you had a data center and you had racks in a data center that were filled with physical computers, and that computer had a hard drive and memory and network IO and some sort of input output. And then what would happen is you'd line up those pieces of hardware on the rack. You'd give each machine an IP address. You'd load some applications in, load some databases in. You might dedicate one machine would be your database server, another be your mail server, A, B, C, D, E, F, G. But the point is that it was physical hardware that was hosting applications and application configuration. Somebody had to put in the operating system. Somebody had to put in the, if there was runtimes like the Java, JVM, applications, database servers, everything had to go on that one physical or array of physical machines, including storage. And what happened is that CFOs looked around and said, hey, I'm spending $100,000 a year on hardware, and my utilization of that hardware is maybe 10%. So the reality is I'm not realizing 90% of my cost. And what somebody did, they came along and said, okay, well, what if we were to tell you we could create a software representation of a computer, and you could host multiple software representations on one physical machine? And the CFO said, yeah, I like that. I'd like that a lot. And that's the virtual machine. A virtual machine is a software representation of a physical machine. So the same dynamics that exist for a physical server, you got to load in the operating system, you got to load in the virtual networking, you've got to load in the applications, the database server storage, all that stuff still exists on virtual machines. The value is that one physical machine can host as many virtual machines as its capacity can tolerate. So for example, if you have a physical machine with 1 gigabyte of disk drive, and I'm making up numbers here, and let's say already at 100 gigabytes of disk drive and 20 gigabytes of memory, you can make 4 virtual machines, give each one 5 gigabytes of memory, and each machine 25 gigabytes of disk space, and each machine is happy and it operates. The drawback is that resource management is a bit difficult. Sometimes it can get static. So for example, if a virtual machine pegs out on its CPU usage or its memory usage, that's it. It's hard to share resources. The other problem with a virtual machine is it takes a long time to spin it up. In the scheme of things, by the time you provision the machine, even with a script, you got to load in the operating system, you got to load in the applications, you got to load in a lot of stuff, and hopefully everything goes right. So the good news is we can realize cost maximization because we get a lot of VMs on a physical host. The bad news is there's still that long load time. So along comes containers, and a container is a way of isolating a process so that it thinks it's the only process in the world. And not only that, a container will leverage existing resources to its benefit. So for example, if the operating system is there, it'll take parts of the operating system it needs and will be able to incorporate that into its isolation. And again, I'm being very trite, almost circumspect about how I'm describing containers. It's a very complex technology that doesn't lend itself well to a 5-minute explanation. But the important thing to understand about a container is that it's a small, isolated unit that can hold a representation of its, how can I say this? Its operating system and application and behavior. There are better explanations. I'll have one later in the discussion. The important thing also to understand about a container is that they load wicked fast. A virtual machine might take 10 minutes to spin up. Some companies are getting containers to spin up in milliseconds. So this lends itself well to the notion of ephemeral computing, where ephemeral computing means I'm going to spin up the resources I need when I need it, I'm going to use it, and I'm going to get rid of it when I don't need it anymore. And containers, they're a game changer. They're a game changer. Docker really did change the world. And Kubernetes is built around this notion of containerized applications and managing them throughout the internet. It's a very powerful technology that's built on another powerful technology. So there's Containers 101. All right, so let me just go. I just want to go over to the side here and see if there's anything coming. No, nothing coming in the chat, so everybody still likes me. All right, good. So now let's talk about clusters and context. These are the foundations of Kubernetes. A cluster is a collection of computers, and in this case, virtual machines. In the way Kubernetes works, it has a fundamental architecture in which there is a master node, which is another name for a computer, a virtual machine. It has a master node that supervises worker nodes. That's the fundamental architecture. So in the worker node, you will have a thing called a pod. And a pod is an isolation unit that can contain one or more containers. Okay, and I'm going to demonstrate this over and over again as I go through the lecture. But the important thing to understand about a cluster is it has a dedicated IP address, and it has a master and at least one node, if not three. Generally, when you do deployments in certain service providers, they like to see 3 nodes out there. And those pods will be distributed among nodes. And Kubernetes has a lot of automagic and automagical stuff that's going to manage pod activity among nodes. And it's where that node is going to be irrelevant for the most part. Where the container is going to be irrelevant. It's really abstracted a lot of physical operation on the internet down into some real fundamental core concepts. And this core concept is a cluster, which consists of nodes, and the nodes contain pods. There's more to come, but let's hold on that. So a context is the binding between a user and a cluster. Okay, a context is the binding between a user and a cluster. Let me elaborate on that. On the right-hand side, you're going to see, you do see, is the configuration YAML for my machine. All Kubernetes installations have what's called a configuration. And that configuration is either expressed in YAML or it can be expressed in JSON. And the configuration will contain definitions for 3 things: the cluster, the user, and the context. And you can see it on the right-hand side. On the left-hand side, I've isolated out the cluster definition for this machine. Yours will vary, but the concepts are the same. On this machine, I have a cluster. I have clusters. I have 2 clusters. One cluster is bound to HTTP 3.5.22.115.22. And I'm assuming you understand IP addresses and URLs. This is my cluster installation on Google Cloud. And Kubernetes made this when I installed the cluster using Kubernetes Magic. And it gave it a name, GKE, with ping around the cloud, a whole lot of other stuff. This is one cluster. This cluster is one master and a number of nodes. There's another cluster that I have access to on my machine. And this is Minikube, and its certificate, by the way, and I'm going to go in certificates later, but this is the access authority, is the certificate, and the server lives at 192.168.99.100.884. And on this machine, this is actually a local computer. And what Minikube is like a sandbox, a playground for how to get used to Kubernetes. You can download it for free. I'll do a class on Minikube if there's interest. But it provides a master and a node that you can play with and get familiar with all the ins and outs of Kubernetes without having to go to the cloud. The important thing to understand is on my configuration, I have 2 clusters defined, one to Google Cloud, one locally to Minikube, and I can switch between those clusters using a thing called the context, which I'll show in a minute, but that is the definition, okay? Clusters, address, name. Cluster, address, name. A user in Kubernetes, there's a thing called a user, but the important thing to understand here, in this machine, I have users. I have one user, Dick Tracy at Minikube, and there's his certificate. This is his TLS certificate. And let's see, and I have another user, named GKE Cloud. Notice the naming gets sort of identical. You have to be aware where you are, but user GKE, Pinger Cloud, etc., has an access token. This is his security credentials. I have another user named Minikube that has security credentials that are stored actually on the machine in which Minikube is stored. And there's a last user at the bottom, you'll see WrestleBob.minikube, that also has its own set of security credentials. WrestleBob at Minikube has fewer permissions than user Minikube. And I did that a while ago. The important thing to understand about users, again, is that in the configuration, you will have a user or users defined. You will have their access credentials defined according to their user, and you will also be given a name, okay? And I'll do a class on TLS about how to define users and do user access. But the important thing here is that users are defined in the configuration. The context, and you can see on the left, I have the context, and I've extracted it, excuse me, on the right, I have the context, and I've extracted it out to the left. The context is the binding of the user with its implicit rights to a cluster. So in this case, I have a context named GKE, Pinger on the Cloud, US Central 1, just a name that Google Cloud generated. But the user, GKE Pinger Cloud, has access to the cluster, GKE Pinger Cloud. There's another context called Minikube, in which the user Minikube has access to the cluster Minikube. And there's a third context, WrestleBob at Minikube. In this case, the user WrestleBob at Minikube has access to the cluster Minikube. However, WrestleBob is not an admin. I did that beforehand, but WrestleBob is not an admin, so his rights are going to be considerably less than Minikube's rights. And again, in another class, I'll discuss security. The current context that my machine, because this is a system administrator machine, is pointing to, the current context my machine is pointing to is the Google Cloud context. And this will become apparent when I do the demo. But the important thing to understand is you have a cluster, which is made up of computers. You have users, which define their name and their access credentials and their permissions. And you bind a user to a cluster under what's called a context. And this is the context. Okay. Masters and workers. And I did this briefly already, but let's review again. A master is a computer that is on the internet, and it has access to nodes, and nodes are workers. The master is the policeman, the nodes are the worker. The nodes know about the master, and the master knows about the nodes. And when I do the demonstration, this will become much more apparent. But again, a cluster is made up of computers in a specific schema. A master is the policeman, the nodes are the workers. Now we got the K8S parts, the Kubernetes parts. And this is a bit of review, and I'm not going to go deep into this, but a master has stuff that a node doesn't have, and a node has stuff that a master doesn't have. And what a master has, it has what's called the API server, the controller, the scheduler, and etcd. The way that Kubernetes works is that the state of the cluster, how many nodes it has, how many pods it has, what's in each pod, what that pod makeup is, the network configuration, that's all known, and it's stored persistently in a name value storage mechanism called etcd. Some of you might be familiar with that. The way that sysadmins talk to Kubernetes is through the API server under a utility called kubecontrol, CUBE-CTL, and that'll come out in the demo. Also, the API server, which is how the master is going to interact with everybody else and the sysadmins, has access to what's called a controller, and there are many types of controllers, and a scheduler. And what the scheduler does is the scheduler is responsible for making sure that pods and other entities are put into the environment when they're supposed to be put in. And some entities are supposed to be there all the time, and some entities aren't. But that exists at the master level. At the node level, you have what's called kubelet, kubeproxy, cAdvisor, and the pods. Kubelet, what kubelet does is kubelet reports back to master the state of the node. And I'm going to jump ahead a little, but I'm going to revisit this too. So for example, let's say you have a node that has 4 pods installed, and one pod somehow goes away. Kubelet will notice that and say, go back to the master and say, hey, I'm supposed to have 4 pods, one went away, give me another pod right away. So kubelet is sort of like the monitor of the node that interacts with master. Kubeproxy is the way that requests to pods are managed through the node. And cAdvisor is it's an observer. It keeps track and monitors the state, monitors information about the node. Finally, the thing to remember is that all the pods, all the containers in a cluster can talk to one another somehow, somewhere. And the way that that interaction is facilitated is through what's called a container, a CNI, a container network interface, if I'm correct. And there are a couple products out there that fulfill that need. It's called the plugin network. Flannel is very popular. WeaveNet is another. When you use a cloud provider, the network plugins are all going to be just taken away from you. You don't see them directly. When you start building your own clusters from scratch, this is going to come into play. Don't worry about it right now. The important thing to understand is that master is the policeman, and it has tools it uses, and node is the worker, and it has tools it uses, and they both have ways to talk to one another. Okay, that's the important part there. All right, and this, I'll put this out. This is just a detailed description of what all the parts do, and I'll put it out on the deck so you can refer to it later. All right, let's talk about the pod. The pod is the building block of Kubernetes, okay? A pod is an isolation mechanism that Kubernetes will install in a node. A pod can have one or more containers in it, and I'm going to demonstrate a pod with multiple containers and how to talk to that. A pod is given an IP address. It is given an IP address by Kubernetes. You can also take control and do what you need to do. Right now, I don't recommend it, particularly when you're beginning. But the important thing to understand is that a pod is an isolation unit that can hold one or many containers. There's reasons why you might want to put a couple containers in a pod, and that pod will have an IP address. It is the fundamental building block of Kubernetes. And I'm going to come back to this. This is never going to go away. It's always going to be here, pod. This is what's called the manifest. The way you describe the state of a pod is through a YAML file or a JSON file, and that is called a manifest. All the Kubernetes objects have associated manifests. They all vary in how the structure of the manifest goes. Some of them, there's some similarities, but there's also a variety. In this case, I have a pod manifest. And what this is doing, let me show you, I have a manifest of kind pod. The name is Pinger, and it has a label, app Pinger. This is very important because when we look at services, the way the service is going to find the pod to use is based on a notion of service discovery. And what service discovery will say is, hey, I have a label definition for my pods, and I'm going to go look for pods that have that label, and I'm going to use them. Don't worry about it if you don't get it right away. We're coming back to it. It's never going away. This pod contains one container. I gave it an arbitrary name, Pinger. I could have called it Mo, Larry, Curly, Bugs Bunny. It's not really relevant. It is relevant in some way, but it's not, there's no naming convention. There's no, how can I say this? There's no standard that names have to go a certain way in order to get Kubernetes to work. And what this container is, it's going to use a container image, and it's this, by default, it will go to Docker Hub. And Docker Hub is where it's the industry standard for where container images are stored. And a container image is the template by which a container, which Docker uses to create an actual container in memory. And in this case, it's going to my repository on Docker Hub and is getting a container named Pinger. And what Pinger is a Node.js application that just sends back some information about its operating environment. It's very trivial, and it's actually, if you go to the GitHub repository that's associated with this course, you will see the Pinger code. And also, it's saying that the container port, the port is going to be running on 3000. Pinger will run on 3000. Also, I am injecting an environmental variable called current version and with the value v1 into the pod, into the container. Excuse me, not the pod, into the container. And this notion of dynamic injection of information is very important. And it has a great deal of impact on those of you that are application developers, because the notion of hard coding environmental information, it's always been a risk, but now it can become a hazard. I'm going to offer a course. I do offer a course on application developers' approach to Kubernetes, and it's based on 12-factor app, how you put in configuration information. But the important thing to understand here is I have a pod. Its name is Pinger. Its label is app::Pinger. It contains one container, Pinger, with a container that's downloaded from Docker Hub. It's running on port 3000, and I injected an environmental variable, current version v1. Okay, and I'm going to speed it up a little because I want to get to the demo. Okay, this is a replica set. A replica set says, and this solves the problem of fail safety that we've had since year one in application development. And a replica set says, I am going to create X number of replicas of a given pod based on a definition. And I, being Kubernetes, will guarantee that that replica count is always in force. Now, replica sets are still in play, but they're not really declared explicitly anymore. Rather, they're used under what's called a deployment. And a deployment really is the definition of an application. Now, just the way that a pod had a manifest file that described its state, a deployment also has a manifest file, uses a manifest file. And in this case, I have one in YAML for the Pinger deployment. I could easily have one in JSON. As a matter of fact, in the demo, I do have a JSON example I'll show you. This deployment says the following. It says, okay, I have a deployment, and I'm going to give it a name, Pinger. I name everything the same. Some people don't. I don't know. Just the way I do things. Okay, and it's going to have 3 replicas. It's going to have 3 replicas of a pod. And by the way, it's going to match app Pinger. Okay, it's going to match labels match app Pinger, and the metadata for each container, each pod is going to be app Pinger, and it's going to have a container, and each pod will have a container Pinger that downloads a container from Docker Hub Pinger running on port 3000, and I've injected the environmental variable current version v1. Now, you might say, gee, that looks a lot like a pod definition. Yes, it does. The deployment does declare a pod schema, but it also declares, among other things, the number of replicas that deployment is going to have. And you can have a number of containers in the pod, okay? So a service, okay, now we're going into service. Let me show you this cartoon. By the way, I do publish a cartoon on devops.com 3 times a week. I recommend you go out and read it. Tell devops.com you love it so they keep loving me. But this cartoon, although it's jovial, it really does describe the nature of a service. So the cartoon says, okay, so what's for dinner? And the waiter says, I am but a service gateway. Sadly, my implementation to which I am bound is not responding. And you say you think they'd have some sort of fail-safety mechanism in play. And what that means is, imagine a service really is the waiter. The service describes, for lack of a better term, the service you can have. The pods are the implementation. The pods are the kitchen. So the service will say, okay, I can give you this sort of behavior, but I'm going to rely upon the pods to fulfill it. And services they get really complex really quickly, and I'm going to go over it now. And I'm going to explain the 3 types of services. I'm going to ask you to sort of just take it with a grain of salt because you need to know the vocabulary, but understanding it takes more than a 5-minute explanation. But anyway, let's look at service. So the way a service works is here I have 3 nodes, a node on the left, a node in the center, and a node on the right. Each node contains a pod, and each pod has a label descriptor of app equals Mo, and app equals Larry, and app equals Curly. Those define those 3 pods, excuse me. And then you can see node 2, the one in the middle, also has pod with app equals Mo, app equals Curly, Larry, Curly, and pod 3 has app equals Mo, app equals Larry, app equals Curly. So there's 3 nodes running 9 containers. 3 containers are dedicated to Mo, 3 pods are dedicated to Larry, 3 pods are dedicated to Curly. Now, above it, here are service definitions. And the service definition, again, this is a YAML file. It's a manifest. It's a type service, and I gave it an arbitrary name, service Mo. But more importantly, it's saying the selector is app Mo. And what the service will do with the help of Kubernetes buddies, all the stuff that's built into Kubernetes, it will go through the cluster and identify the places where pods with the service label app Mo are being run, regardless of what node it's on. The same thing with service Larry, and the same thing with service Curly. So the service, this allows you to expand pods, decrease pods, change behavior without destroying your interface into that behavior. The service is the interface, the pods are the implementation. Okay, so again, this is the service manifest for Pinger. which I'm going to demonstrate to you in the deployment. And you can say it's a service. The service name is pinger. There's the selector. It's going to look for all nodes that have an app equals pinger in it. And it's protocol 3000, target port 3000. Those are details I'm going to cover in a minute. And type node port, which I'm going to cover in a minute. Don't get all hung up. Really understanding service types is a class unto itself, but I'm going to explain it now just so you can get a sense of what it's about. There are three types of services, three types of representation of behavior in a cluster. And in a cluster, the most important concept to understand is there's in the cluster and outside the cluster. In the cluster is like it's like your house. You know about everything in your house, and how it works in your house is fine. You don't let anything into your house. You probably have a doorway. That's outside the cluster. And the world inside the cluster is different than the world outside the cluster. When you assign a service of cluster IP, what it will do is it will create it being Kubernetes, will create an IP address that's dedicated to the service that is only visible within the cluster. Okay. So what that means is that things inside the cluster, other services and other entities inside the cluster have access to that IP address. Okay. It's a detail, it's an important detail. It's just not one to get hung up about right now, but the important thing to understand is there is a service type called cluster IP. Another service type is called node port. And what happens with a node port is Kubernetes will create an IP address that is visible outside of the cluster. And what it will do is give that IP address a particular node that starts above a range 30,000, port. It'll give it a port that begins above the range 30,000. And that port will map back into the port of a given service. Okay, the node knows about its services and knows about the pod, knows about a lot of things, but it'll say, okay, here's an IP address that'll describe that'll describe this the service to the outside the cluster. Here's a port that I'm going to create on the fly, and I'm going to map it to port 80 on, in this case, port 80 on the service, and in turn, the service will map to all pods. Will open up IP addresses, a port 80 on all pods in the cluster. Whew, that's a lot to say. Again, it's a very complex topic beyond 5 minutes, so I'm not going to belabor it. The important takeaway here is to know that the second type of service is a node port. The last type is a load balancer, which is what we're going to use in the demonstration, which says I'm going to create a load balancer that's exposed to the internet. The load balancer knows about the nodes, and I'm going to be able to negotiate traffic between the outside world on the internet and the inside world in the cluster. And that's load balancer. So again, service has three types: cluster IP, node port, load balancer. And granted, yes, I could have probably done a whole lot better explaining it. I will do a course that is completely focused on this, that you can talk about in the evals and say, yeah, I want to take that course. All right, let's talk about Ingress, because Ingress is really the mechanism in Kubernetes by which you can route any traffic coming to a load balanced IP address into the cluster. What do I mean by that? And Ingresses are very, very cool. It solves a lot of problems, a lot of DNS problems, like, oh no, I want to put more hosts out there, but I don't know how I'm going to map them back to my applications, and all that sysadmin, DevOps, hairy, detailed, oriented routing stuff that everybody would wish went away. Well, it does go away under Kubernetes. And an ingress is a definition, and it is described in a manifest. And what an ingress says is I will take any traffic that comes to me at the IP address, and I will decipher it and send it to the proper service. And that deciphering is done according to the host definition and the path definition. So for example, in my ingress, I might say, okay, any IP address that comes by IP address /mo, as a URL, I'm going to port to the Mo service. IP address /Larry that comes in as a URL with that URL, I'm going to port to the Larry service. IP address /curly, I'm going to port to the curly service. However, if traffic comes to me with a host name of curly.com, I'm going to be smart enough, I being Kubernetes, to actually then route that to the curly service also. Okay? Now, what I'm going to do is in the demonstration, which is going to come up in about 2 minutes, I'm going to show you an ingress that's going to take 3 paths, one at the root and send it to the pinger service, another one it comes /pong and send it to the pinger service, and another one /ping and send it to the pinger service. Again, the important thing to understand about Ingress is that it is the Kubernetes mechanism by which routing internet traffic coming at an IP address can be routed to just about anywhere within the cluster. Okay, it's very, very powerful and very, very cool. So this is the definition of an ingress. This is the manifest. This is the YAML. And up here, what it says, I went outside my pattern. I said, okay, I have an ingress named pinger-ingress, and I'm going to default it to the backend service pinger at 3000. And I could put a host in here. And in other classes, when I talk about ingress in detail, I'll talk about how to do hosting and have DNS records and all that manipulation. But the important thing to understand here is what I'm saying says, anything that comes at me at the root, send it to the pinger service. If it comes in /pong, send it to the pinger service. If it comes in /ping, send it to the pinger service. And this is just going to happen automatically. It's pretty amazing. There are people out there that control all their routing through the ingress definitions. And again, I'm probably being boring at this point, but it's an incredibly powerful technology. All right, so let's do the demo. So we got to say to demo gods, okay, demo gods, please work out. Please work for us today, okay? And I'm going to do that. And now I'm going to do demo. It's 8:08. I'm going to try to get them by 8:30. So let me get out of here, and I'm going to, I'm still going to share because this is my screen. And you should see, everybody should be seeing my terminal. And if you're not, I'm looking at the chat window. If you can't see the terminal, say you can't. And if you can, I'm just going to say hi, just so you know, I'll go, hi there. So I'm going to move my microphone off of my keyboard. If you can't hear me, just say I can't hear you, okay? And I'll see it coming through the chat. So I'll go hi there, okay? Not recognized, but I'm going hi there. Okay, so now let me clear off the screen. And again, the way we talk to Kubernetes is what's called kube control. And kube control, you download it from the Kubernetes site, and I'll put that out on the follow-up URLs about how to get what you need. But kube control, just think it's kube control is saying, Kubernetes do this. So right now I'm going to say Kubernetes config, view the configuration. And there you can see, there's my configuration for this machine, okay? And I know it should be configured. It would be nice if it said kube control view config, but I guess the guy that programmed this had other things in mind. But there's the configuration. And I can also say, let me clear my screen again. And right now I really am pointed at Google Cloud. So I'm going to go Kubernetes, kube control, and then I'm going to say get, and that's a verb. That's how it should be. And I'm going to say get node. And what it's going to do, it's going to go out to Google Cloud right now, and it's thinking, and there's all the nodes, all the worker nodes in my cluster. And that's pretty cool. That's pretty cool. And now you might say, well, that's cool, but show me something really impressive. So I'm going to go Kubernetes, kube control. And then what I'm going to do is I'm going to say, do me a favor, here's a verb, describe, and I'm going to pick a node. And Kubernetes took over naming of the nodes. I didn't, actually Google Cloud did. So I don't control that anymore. But I'm going to say, look, please, Mr. Kubernetes, Ms. Kubernetes or Kubernetes, please describe the pod that ends in BV. And now it's going out, and the internet is pretty slow tonight. It doesn't have a resource. Oh, no wonder, I'm sorry. Duh, shows you what I know. There's no magic here. Kubernetes is powerful, but it's not magical. Please describe the node. What node, Bob? Okay, it's node, please describe this node. And there it is, and that's the description of the node. And you can see, if we look at the bottom here, now I'm gonna go down, you can see I'm highlighting. These are pods that are running already on the node, and you can see that Kubernetes threw a lot of stuff in there for free. Okay, there's nothing really that I put in there yet. This is all the Kubernetes stuff. but it's reporting a lot of information. So you're going to find that the describe verb is a very, very powerful verb that you can use over and over again. Okay? All right. So now what I did do is prior to this class, I did already install one pod. And I'm going to go kube control, which is Kubernetes, and I'm going to say get pod or pods, but it really is pod. And right now I have one pod out there and it's called Nginx Pinger. And Nginx Pinger contains 2 containers. And I'm going to show you what that is later on, because what happens when I start creating this cluster and I put the Ingress in, there's about a 3-minute wait while Google Cloud figures out how to create the load balancer to bind to the Ingress so we can all talk to it on the internet. So I'm going to come back and revisit this in a bit. But right now, the important thing to understand is there is a pod out there. What node is on is completely irrelevant, but for now, but it is, and you can see 2 of 2, and it says there is actually 2 containers running in there, and they're both happy. Okay, and it's been there for 11 hours. Okay, and that's good. Now, so let's go back and let me go cat. I've prepared this. I'm going to go cat manifests, and I'm going to look at the deployment. And this is the deployment that I showed you earlier, Pinger, 3 replicas. And I'm going to say Kubernetes, put this deployment out on Google Cloud. So what I'm going to do is I'm going to go kube control, Kubernetes. I know, but that's because of the line segmentation. And then I'm going to say apply. And in Kubernetes, you can apply files, manifest files directly. And in this case, I'm going to say apply deployment. And it's going to go, and it's going to say, Bob, learn to spell, because it's not appy, it's apply. Hey, it's, if those of you that are not in Los Angeles, if you're like in the East Coast, you're probably falling asleep by now. And if you're on the other part of the planet, you're probably wide awake. But you can see that now the deployment has been created. So what does that mean? So let me clear the screen again. And let me go kube control, get pod. And now you can see there's 3 pods running. And the deployment did that automatically. It just happened automatically. And you might say, well, that's nice, Bob, it really impressed me. And I'm going to say, well, you know, I can talk to a container in that pod anytime I want to. And the way I can do that is I'll go kube control, exec, okay, which is, exec is a verb. It says execute something into a container. And I'm going to say use the standard in. And I need to pick a container. In this case, I'm going to exec into the container. It's Pinger, the one that ends in 2F. And I'm going to say hit implement the shell. And now I'm in the container. You can see the prompt has changed. And if you look, there's the, it's like I'm in a machine. It's like I'm in a computer. And you can see over here, there's the node application. All right, but what's more important here, if I go to environment, you can see there are the environmental variables. So not only when I created the container did some of the stuff that I wanted to be put in there. Remember I said current version 1, there's my injected environmental variable. But also Kubernetes put a lot in there too for free. So there's a lot going on. So that's nice, but it's not terribly impressive because I say, well, gee, I'm going to start battling Kubernetes and Kubernetes is going to win. So one of the things I can do is I can actually increase the number of pods in play. And there's a variety of ways to do that. And one of the ways, it's called kube control, Kubernetes, edit the deployment. And in this case, the deployment name is Pinger. And if I edit the deployment, it's going out and it's pulling the deployment information off of Google Cloud. And you can see that if I scroll down, one of the declarations I have is the number of replicas. It's 3 now. And what I'm going to do is I'm going to say, no, I want to boost it up to 7. So I'm going to boost it up to 7, and I'm going to get out of Vi. Okay. Now I'm out of Vi. And now, if I go to get pod, you'll see there's a lot of activity going on, that new containers are being created. And that's good, because I said I want to see 7 containers created. If I go again, you can see they're all running. Wasn't that wicked fast? That's just wicked fast. I mean, think about how long it would have taken for virtual machines to spin up. And you can say, okay, well, that's nice, but show me some more. Okay, so what I'm going to do is I'm going to get the pods again. There's a pod, and I'm going to go kube control, Kubernetes, delete a pod, and I'm going to pick a pod, any pod, and I'm going to pick the one ending in QT, remember that? And I'm going to say delete pod, QT. And the pod is deleted, excuse me. And I'm going to get the pod, but notice what's happening. Notice that as one pod is being deleted, another one's being created. And that's the state persistence that Kubernetes guarantees. And that is so wicked cool. All right, that the state will always be there. Now, that's not to say that problems don't happen. Believe me, a lot of problems happen. But it's nice to know that the baseline contract is if you declare a state, Kubernetes will maintain it. And that's very cool. Now, let me go out to here. And let me go grab, I got to grab something because I'm not a very good typist. So let me go here. And I'm going to say, I'm going to actually patch. I'm going to patch the deployment completely. And what do I mean by that? Okay, let me put in the patch. And this is the verb, Kubernetes patch. And I'm going to patch deployment pinger. And I'm going to say, go out and do me a favor. Change the current version, in the environmental variable current version, and inject in a new value. And also inject in a new environmental variable called secret message. And the secret message will be kube is cool. So I'm going to hit enter. And now you can see that the patch has been deployed. And now I'm getting more activity because what's happening is Kubernetes is saying, okay, you want me to patch this pod. I need to get rid of the old ones, put in some new ones with the new information. And I'll do that and I'll maintain state. So your users might experience some difference in experience, but the state will eventually be implemented. Now, also, I'm not going to demonstrate it here, but there is a rollback, a way to roll back deployments. So if you don't like what you did, you can just roll it back to a previous point in history, and it's like nothing ever happened. So that's very cool. So let me clear here, and let me go back to get pod. Now, as you can see, we're still terminating, but I'm back there in my 7 pods. And what I want to do is I'm going to go back in. I'm going to go kube control, exec, IT, respect standard in, and I'm going to pick this pod. Seems to be, I'm going to pick the newest one, 6 seconds. This is the newest pod. So I'm going to pick that. Okay, IT, and I'm going to say implement, go ahead, do a little SH action. And now I'm back here. And then I'm just going to get the environmental variables. And as you can see now, there is the new environmental variable injected. And also there is current version should be ticked up to V2. So that's very cool. So now I can start playing with deploying. I'm not married to anything. Everything becomes ephemeral, everything becomes dynamic. That's really nice. So let me exit here. Okay, let me clear. And now, okay, so I got behavior, but it's still not accessible. It's still not accessible. So what I'm going to do is I'm going to implement the service. And I'm going to use a YAML file, manifest, and this is the one I showed you previously. I'm going to create a service, and it's going to go look for all pods that have an app label, app pinger, okay, and it's going to go hook into 3000, and it's going to expose. The service port will be 3000, and it will also expose the pod port 3000. And again, that might seem a little confusing. Those of you that use Docker, that you're used to run ports and target ports. But again, I'll go to it in an advanced, another class which is called Beyond the Basics. But if we look, let me go to kube control. I'm going to go get service. And there's the service. And it is, oh, wait, it's not. What happened here? Oh, I didn't, oh, duh. I showed you, excuse me, I showed you the file, but I never implemented it. So now that you know more than I do, we can go kube control. I'm going to apply what? I'm going to apply F, and I'm going to go to manifests, and I'm going to go to service, which I showed you earlier. Now I'm going to apply the service. And the service is created. Let's go back. And you can see there's the service. It's of node port, and there's the IP address internal to the cluster. Now, I'm going to describe the service. So remember earlier I said Kubernetes, describe a service, and I'm going to describe the service pinger, which coincidentally is the same name as the deployment. And now what's interesting here is if you look at endpoints down here, the service has gone out into the cluster and has found the pods that it needs to use. Okay, so those are called the endpoints, and that's really good. And how did it know the endpoints? It knew the endpoints because it was looking for that label app::pinger. That's very nice. Okay, so that's done. Now we have a service running, but we still can't get to it from the internet. And there's ways you can get to the service internally, but I'm not going to go into that right now because we don't have a lot of time. And I do want to get the Ingress up and running. So let me cat manifest the Ingress. Okay, and there's the Ingress, and basically that's what I showed you earlier. I'm saying, gee, if any traffic comes at my load balancer IP address at the root, point them to the pinger service. At the if it comes in /pinger, /ping, point them to the pinger service, and /pong, point them to the pinger service. And the pinger service just reports state information. It's not a rocket science application. So let me deploy the Ingress, and I'll do apply /f, file, manifest, and Ingress. And now the Ingress is going out, and let me do kube control, hit Ingress. And now you can see that the Ingress is created. However, there is no address yet. And the reason there is no address yet is now we're leaving it up to the Google Cloud gods to do what it needs to do. Create the load balancer, assign the IP address, and bind that IP address back into the services. And it will happen. It will happen eventually, and it usually takes about 2 or 3 minutes. So in that time, I want to go back to the multi-container pod and talk about it. So let's go back to kube control, pod. Okay, and there's Nginx pinger, right? And I'm going to go kube control, Mr. Kubernetes, Ms. Kubernetes. Kubernetes, please describe the pod, and the pod is pinger. And now you can see there's a lot of stuff in here, but it's saying, look, I have 2 containers, and one is listening on the host port 85 and will route back into my port 80, standard Nginx stuff. And there's pinger listening on the pod is listening on 3000, and it will go back to the host port's 3000, and it will go back to the container. So the container's in there. But wouldn't it be like really cool if I could talk to each container in the pod? So why don't I? So the way I do that is I go kube control, and I use the exec again, and I go IP, okay? And then I'm going to say this, I happen to remember now, it's Nginx pinger. And now what I'm going to say is talk to container. Which container? Excuse me, Nginx. And I'm going to say load up the shell, load in the shell for the Nginx container. Okay, and I do that, and I wait. And there it is, I'm in. So how do I know I'm in Nginx? I'll go which Nginx. For those of you that know Linux, this is familiar. For those that don't, I apologize. I would do a window. But this is it. So, oh, there's Nginx. It's happy. Nginx is there. It's running. So that's good. I'm literally in there. If I go ls, there's the file system for that container. Let me get out of this container, and let's go into the pinger container. So if I go to pinger, and saying same thing, go into the pod, go into the container and run the shell. So if I go to shell, okay, there it is. And if I go to ls, you can see there's right here, there's the node application that's running. So I'm inside the pinger container. Let's see what we have for environmental variables. I have pinger rocks, right? So that's distinct. I have an environmental variable that's running dedicated to that container, and that's really, really cool. So what have I demonstrated? I said, okay, you can have a pod, and a pod can have multiple containers, and I can talk to each container directly, as can Kubernetes. And there's reasons for that, which I go into in another class when we go beyond the basics. Okay, so let me go here, let me get out of here, and let's see if the IP address has come around yet for the Ingress. Boom, there's the IP address. Okay, so Google Cloud has done its magic, and it's saying, okay, I'm going to create the Ingress. You have an access point. There's the IP address, and then hopefully it's bounded to the service. Let's see if it's bound to the service already. So I'm going to curl the IP address, and if you can, then you can go to your web browser if this works, because the service binding might not be there yet. Yeah, we still got to wait. Hold on, it will show up. All right, let's go back. While we're waiting, what I'm going to do in the chat window, I'm looking at the chat window now. It's going to take another minute or two for the service bonding to happen. But in the meantime, if you want to have any questions, please put them in the chat window, and I will bring the chat window over here so people can see it. And if you have a question, please pose it to me now, and I'm happy to answer it as best I can. If I can't, I'll contact you offline, and we can go into it in detail. So I'm sitting there looking. I bet you everybody's watching YouTube now. World Series isn't happening. Oh, it's Thursday night football. Right. You're all watching me in Thursday night football. So I understand, but I'm sitting there waiting for some chat stuff to come up. No chat yet. All right, let's see if this has come back. It's still taking. No, I mean, yeah, it takes a while. The internet works differently in California in the evening because I think we're laid back. Keep in mind, what's amazing here. What is amazing here is that what I am controlling now, I am controlling all over the planet. This is now visible all over planet Earth. This is going to the appropriate data centers in planet Earth. Oh, what do you mean by that? Let me show you one more. Let me clear the screen, okay? And let me go back to kube control, get node. Okay, there's a node, and I'm going to go back and describe a node. Let's go to kube control, describe node. And I'm going to pick a node, any node. I'm going to pick this node, okay? Okay, and that's one of the nodes, and it's going to describe. And if you look down here, you see at the bottom, I'm highlighting at the bottom of the screen, there are 3 containers of the pinger containers. Remember, there's 7 in play. There's 3 of them on that node. And so do I know what data center this node is in? I have no idea. Maybe I could find out. Maybe I could find out an IP. Maybe I'm selling myself short. But the important thing here is to understand that this is worldwide stuff. And run from the comfort of my desktop in West Los Angeles, I am committing code that is going to have an impact worldwide. I find that to be pretty amazing. And I find that to be pretty amazing. But let's go back here. And now you can see the service has been bound to the endpoint. Now, let's pay attention to some stuff. And for those, I'll tell you what I'm going to do. I'm going to grab this. I'm going to grab this HTTP thing. Let me go out to my web browser here. Okay. And I'm going to go to the web browser so you can see it. And let me open let me get the chat out of the way. And then here, now you can see here. Okay, now you can see that, first of all, it's this is coming off of this IP address on this pod, and you can see it's coming in at root, okay? Let me go to ping and see what happens. Okay, so if I go to ping, now you can see the URL is ping, it's coming in on 48, but it really is the same logic. It's the complete same logic. And what's also interesting is you can see the current time is 2048, and here's the start time of the pods, which would be interesting for comparison. There's the secret message, and it's running on this pod in this container on this process ID. Let's go to Pong. Remember we were at 48. It'll be interesting to see what node we end up on with Pong. See, Pong is now at 52. It's on a completely different, it's in a completely different pod. So it's going all over the world to operate. And you people can do it at home. I hope you do, because I really like to see things going around. We go back to the root. Okay, and now I'm back, I'm back at 52. Let's go, oh, sorry. Let's go to Pong. There you go. Okay, 47. So I'm going all over the place, and that's good. All right, so let's go back to K8 here, because I'm coming to the end. I don't want to go full screen yet. This is the output that I showed you for the demo. Okay, you've seen this before. Now, what I've demonstrated is I showed you what a node is and a master node, and I showed you the pod and how it holds containers, and I showed you a deployment, which is a way of orchestrating pods under a single umbrella called a deployment, and I showed you a service, and I showed you an ingress. And this is a picture. If you run on a Fedora Fedora server, you can, under its cockpit utility, there is an add-on called Kubernetes, Cockpit Kubernetes, which actually give you a visual representation of what your cluster looks like. And this is a snapshot from one of my Fedora ones that I have on in another place. But as you can see here, what it's saying is, okay, there's your node, and here are pods. This node has a number of pods. This node has a number of pods, but also this pod is represented by this service. And you can see here that this service is represented by this pod, this pod, this pod, and they're all on different nodes. So this is a really good graphical representation. In another course, when I go into dashboards, Kubernetes does ship with a dashboard you can install. And then there are also just more advanced add-ons like Grafana and what's the other one? Prometheus. That'll show you I'll show you the state of your clusters. Datadog, who I have a fondness for, they're doing a lot of work in the Kubernetes cluster area too. Also around transactional tracing. What happens when you have a web request that goes out through the planet and it goes to so many different servers? How do you keep track of what's going on? So that's the big picture. So let me go back to the beginning here for a minute because I want to make sure our contract has been kept. I said in the beginning, I'll show you what a node is. Again, a working vocabulary. A node, machine in a cluster. Pod is an organizational unit that holds containers. A deployment is an organizational unit for pods. A service is a way to bind access to pods, and an ingress is a way to bind internet access to a service. And that's your working vocabulary. There's a whole lot more that I didn't go into. Because one of the things we haven't discussed is, gee, how do I store data? Because the thing to remember is if you're storing data in a pod and I go and delete that pod, that data is gone. It's not coming back. So if you have, even if you're smart and say, I'm going to create a WordPress deployment that's going to bind to SQL Server pod and a WordPress application, and I go in and I delete that SQL Server pod, unless I make arrangements, that data is gone. So that's one thing we need to talk about is how do we persist data. Namespaces, I didn't talk anything about security, which is bad business. I've pretty much shown you how to destroy your life with no security wrapped around it at all. And namespaces and RBAC roles-based access control is a critical concept when working with Kubernetes. How do you let things that are supposed to get at things get at things? Daemon sets says I need to be able to put intelligence on every pod that runs all the time and monitors what's going on in the pod. I can show you health check says, how do I know my pods are healthy? Dashboards allows me to view pods. Monitors allows me to get the state of pods. The last thing I want to show you before I bring it to a close is just to give you an idea of the breadth of Kubernetes. There is a verb you can run in kubectl, and it's called kubectl API resources. Those that can type. And it will give you a list of all the objects in Kubernetes. And each of these objects is at least a day or two worth of study. My theory has always been, if you're a developer, it takes you about 5 years to get good at it, starting from scratch. For Kubernetes, it's going to take you about a year and a half to get comfortable with it, and then to get good at it, throwing another 6 months to a year. But you got to start someplace. All right, so again, here is the stuff here. Pinger, go out there, you can take a screenshot of this, or I'll put it on the meetup site so you can get more. There's my email address. And more importantly now, here, and this is what I'd like you to do, is go take this survey. It's a Survey Monkey. I'll put it in the chat window. It's coming. Hang tight. Well, thanks for coming. I know it's late, and particularly for those of you that are not in California or on the East Coast, I really do appreciate the time you've taken to spend with me and get to know Kubernetes, because it is an important technology. Okay?